This is my replica of a 1798 pattern Highland broadsword hilt. I loved the raked profile these had, as well as the etching you often see on historical examples. But unlike those, this one is stainless steel, not brass. Likewise, the blade was made traditionally, but the hilt is 3D printed. Even the grip is actually plastic. But it's not just this one that's printed. Could do a Highland broadsword with quillions, one without the quillions, this twisted little rapier design, and its matching dagger. And of course, some complete science fiction saber stuff. Today, we'll discuss designing and fighting with 3D printed steel sword hilts in historical European martial arts. Spoiler alert, they work. And if you are watching this, love swords, and have even basic skills of digital design, you could very easily make your own functional sword parts. So, today, I'll be covering how they perform and how you could make your own. Let's cover some basics first though. To do this, we're not melting plastic with a hobby FDM printer. We're using SLM, or selective laser melting. That produces metal objects from powder melted with a laser. Given that the cheap machines in this category are tens of thousands of dollars, you're probably not doing this at home, but this is very easy to rent, as we'll discuss later. And just to get it out of the way, no, you cannot make sparring blades with this method yet. This stuff won't behave like the high carbon spring steels needed for flexible blades, and the places that can make objects that big won't let you touch their machine. One more thing, you'll see a lot of references to Highland broadsword in this video. This is a great test for this because it's subject to tremendous force and real ones are expensive. Which leads to our first question. How durable are 3D printed hilts? SLM 3D printing can support a bunch of different metals like titanium, aluminum, stainless steel, with different strengths and prices. As you can imagine, even if you have the right knowledge about metallurgy to understand material strengths, practical examples are much more useful. To do that, we need a baseline. How strong should a 3D printed hilt be? Let's look at how traditionally made hilts performed, with some samples from some well-known brands. As far as I know, these are all cut from sheet metal, then bent into shape and welded together. As you can see, these look pretty banged up. I fence twice a week if I can. You'll see the same pattern of damage after a couple months with pretty much any of these. First, starting with the horns crushed inwards. This usually happens within the first couple sparring sessions. As you can see with all of these, they've all been quite a bit banged up. Completely ripped off of this one, for example. Second thing is cracks forming along weld points and thinner parts. I've rewelded this one 10 separate times maybe after 2 years of use, starting from the first 2 months. Let's go have a look how many we got here. Here, 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 one in there. Last but not least, let's talk about deformation. Metal's gonna crush inwards, point where it needs to be hammered out so your hand can fit again. Pretty obvious with my first broadsword over here. And even for much fancier ones, like these armor class hilts, I'm one of, I think, 3 or 4 people I know who've welded some kind of ring to the bottom so that it holds its shape better, because it'll lose it after maybe even a week or 2 of fencing. Our benchmark is in fact pretty low. Can we make a hilt that stands up to regular sparring for a couple months without crushed horns, cracks, or significant deformation? How did we go about testing this? We'll go into detail on the design process a bit later, but I knocked up a honeycomb shell in Fusion 360 without the horns, 3mm thick, and I ordered it in miraging steel with a heat-treated and unheat-treated version to be sure. 2 weeks later, and I've got the real thing in my hands and I'm ready to test. But I'm not going to risk my fingers by getting into a fight with it just yet. We're going to start with some scientific bench testing. Looks like someone's ready for field testing. Printed out some handles, mounted some armor class blades on them, and got to work. 3 months later, there wasn't really any damage, dents, cracks, whatever. Obviously, I'd underestimated the material and the process, so it was time to try something a little bit more delicate and extravagant. So, second design, bunch of intricate bar work, some big quillions. Let's see how this fared. Likewise, I went with a cheaper metal, 17-4pH stainless steel. More than 6 months later, I've been unable to break them in a fight, so I'm happy. Moving from curiosity to obsession, I started focusing on more traditional designs. This is the point where I started recruiting guinea pigs, who were also using the swords a hell of a lot more than me. Conclusion, the results so far are very encouraging, and since then I've made more wacky stuff and more styles that seem to prove the method works. I did find one place where you might need to pay a little more attention when designing, but we'll cover that in a second. Speaking of, let's talk about how you can do it yourself. There's a few steps we'll cover. First, designing and testing the parts. Then, paying a metal fabrication shop to take those designs and send back complete parts, followed by any subsequent polish, fitting blades, grips, that sort of thing. The first and hardest part will be designing your 3D model. There is practically no plans available online right now, and even if there were, you have to design around a blade you already have, so chances are you'll need to do a little bit of work. So many ways to approach this, but I'll cover my process. I use Fusion 360 as my CAD tool of choice. There is a free version that does everything you need to do, and there's heaps of help documentation online. If you've never used these kinds of tools before, plenty of great tutorials on YouTube. I'll link some in the description. CAD is a huge subject though, and for our purposes you kind of only need the basics. Let's run through a quick example making a messer hilt just to see what's involved. First thing I'll usually do is set up some parameters for measurements I'll be using, like length of quillions or thickness of metals. 360 works with a timeline, so if I change any of these numbers later, the whole thing will recalculate, which trust me you'll want to do often. I'll then start with a profile sketch of the side or the front. Sketches are the 2D blueprints you create all your 3D shapes from, and typically you'll put a bunch of those parameters you just made in here. In this case, I'm going to draw the tang of the sword first, so I can build the hilt around what I have. Usually I'll take a bunch of measures with calipers to get something exact to work with. I'll then extrude that out into a complete shape once it's done, and then we're ready for the next step. We'll then start with a side profile of the hilt, first by drawing the quillions with some very basic detailing at the end, followed by the knuckle bow. I'm using the offset sketch tool to ensure all the thickness from this dimension remains consistent. Might as well do something really lazy for the pommel here, make it a wheel. Great. Done. After a few adjustments, even though we're going to print this handle out later, we might as well design that while we're in here. Looks like we're ready to turn this into a 3D shape, so we'll select the whole thing and extrude it out. We'll also bulge it out even further where we've got the tang. We'll then use the fillet tool to blend that back into the rest of the design. Trust me, you'll be using the fillet tool a lot. In fact, I'm going to pause here to talk about the one durability issue I have come across. Having sharp corners subject to significant force leads to stress points in your design, which could easily lead to breaks if there's imperfections in the print. It seems to be a factor in the one break I've had in a fight after making a dozen of these, and something I've been warned about from the experiments of others like Jess Belsky's Stage Swords, who's been using this technique longer than I have. So, approach 1. Anytime you have significant force on a point with a lot of leverage, like quillions, make sure you've got a nice bit of filleted curvature to stress relief that area. You can also mitigate this problem with some trade-offs from materials. The two metals you probably are most interested in are 17.4 pH stainless steel and 316L stainless steel, which are very common. They also have dramatically different properties. The former is very strong, very hard, but the latter will bend quite a bit before breaking. So if you're designing something with big quillions subject to a lot of leveraged force, it might be a better bet with the 316. On that note, we'll use the chamfer tool to soften these edges a little bit. We'll then build out the pommel the same way as we have the rest of the hilt. Then use the chamfer tool to give it a little bit more shape. And then build out the grip as well, using the same techniques as before. Extruding, chamfering, and filleting to get the shape we want. Let's also add some thread to the pommel. Keep in mind metal printed threads at this scale are a bit too coarse to actually work, but every manufacturer I've worked with is completely aware of this and will re-thread them for you if you ask. Now, if you've never done CAD tooling before, this is probably a good exercise to get started, but obviously to make something interesting you need to do a lot more. So, for example, I want to add some side rings, so I use multi-dimension sketches to give them some shapes in other axes. And once you've got multi-dimension sketches down, start using the loft, pipe tool, emboss, any of those other things, and that allows you to create really cool 3D shapes you can work with. Okay, so once you've got a basic design, the next step is going to be testing it before we go and do something expensive like get it made in metal. So in this case, I'm going to be printing it in PLA. Obviously, that's a pretty cheap, easy way to do things. So yes, even though I'm talking about metal printing, realistically, I think to have any luck at actually delivering this kind of stuff, you're going to need a plastic printer to test your work. Because you'll be going through a lot of it. Let's say you're happy with the design and it's time for production. There are plenty of online services that do this. In addition to the ones I'm talking about, you can find one locally, and it's very easy. A lot of them have online portals you can submit your model to, select your materials, and all without talking to a human being, and get a real product within days. Let's take a second to talk about cost. These aren't super cheap, but they're not super expensive either. For example, these ones here, yes, they're a couple hundred USD. They're also quite a bit cheaper than the equivalent one from name brand manufacturers. This does tie into the next step though. Unlike something you'll get from a reputed blacksmith, these won't come polished. They won't come cleaned up. You're gonna have to take the sandblasted one they give you and turn it into something pretty. I was able to do this with nothing but a cheap drill, some wire brush attachments, and flat wheels, but it was still an hour or so I spent on each one, and a completely separate skill I'll need to get better at. Thing is, that's the only manual labor needed for the whole process. Slide in a printed grip, and that's pretty much it. You are ready to go. I might actually stop there for now. That's a pretty solid primer on all the basics. 3D printed metal is becoming a bigger thing in manufacturing, and it's only going to get cheaper and easier. I don't think the costs and margins are quite there yet for this to replace carbon fabrication methods big workshops use for swords, let alone more traditional makers. But for small runs or bespoke examples, it is a game changer, and I'm definitely excited to see this process evolve. You might also be wondering if you can grab some of those designs I've shown here for your own sword, or to use as a reference with your own work. I'll put some links in the description if you want to use these models as a reference, or to even make your own sword, remembering they'll need a little editing to fit whatever pommel or blade you have. You can even check out some of my other junk. What's next? No idea. I've still got a huge backlog of footage from a project to make a bunch of HEMA-safe polearm heads with custom molds I've yet to put together because video editing is the devil. There was also this thing of trying to make a really non-reflective saber with like black 3.0 ultra matte black paint, and it didn't work. Don't worry about it. Or maybe finally finish that scale model of the HMS Surprise I was trying to design for my other channel. Let me know in the comments if anything really excites you. Have a good one.